Okay, so this is 7 rational equations. We want to start out with a definition. So, rational equation is an equation that contains a rational expression. Okay, so it's just like when you were solving, working equations that have fractions in it. We're going to have a lot of similar concepts here. So let's look at example 1. We want to solve. So when they say solve, you should be able to get it down to some point where you get like x equals some number or whatever, as opposed to simplify. So A, we got x over 4 minus 2x over 3 equals 5 over 6. Okay. So to get rid of fractions, how do you get rid of the fractions? You multiply by the what? The LCD. Okay. What are the LCDs of these fractions? So let's take the largest denominator, which is 6. Is 6 a multiple of 3? Yes. Is 6 a multiple of 4? No. So then we're going to multiply this by 2. Is 12 a multiple of 3? Yes. Is 12 a multiple of 4? Yes. So then the LCD is 12. So I'm going to multiply this times 12. I'm going to multiply this times 12. And this times 12. Okay. So 12 divided by 4 is 3, and so we get 3x. 12 divided by 3 is 4, and 4 times 2 is 8, so that's 8x. 12 divided by 6 is 2, times 5 is 10. So then that's a negative 5x equals 10, so then x equals a negative 2. Okay. You would check by plugging in, but yeah, negative 2. Let's look at B. We have 2 over p minus 4 over 3p equals a negative 1 over 6. Equals a negative 1 over 6. And they give us that p is not equal to 0. Why is it that p can't be 0? Because you can't divide by 0. Okay. So now, what is our LCD in this case? We're going to do the same thing. We just need to identify our LCD. Okay. So the highest exponents on the p's is p, and the 6 will cover, the 6 is the LCM of the 3 and the 6, so then it should be 6p. Okay, so we're going to say this times 6p, this times 6p, and this times 6p. Okay. So the p's are going to cancel here, and that leaves us with 12 minus. The p's are going to cancel here. 6 divided by 3 is 2, times 4 is 8. And the 6's cancel here, and that leaves us with a negative p. So then p is going to be negative 4. So we want to solve. So we the denominator is 2b minus 1. The numerator is 3. And this is equal to 4 divided by 3b. Okay. So whenever you have a fraction, well, we could do the same thing by multiplying by the LCD. I'm going to do this technique. Whenever you have a fraction equal to another fraction, you just cross multiply. Okay. So now I'm going to cross multiply. So then this is going to give me 9b is equal to 8b minus 4. Subtract 8b and you get b equals a negative 4. And you would check it by plugging it in. Did I mix up some things here? So we can go with that example. Yeah, so negative 4. Okay. So here are some steps to solving a rational equation. Okay. So you want to find the values that make the rational expression undefined. Okay, so in other words, any variable that makes the denominator 0, you have to exclude. Then we find the LCD, multiply both sides by the LCD, and then resolve the resulting equation. That's not what we did in the last one. The last one we just cross multiplied because we had a fraction equal to another fraction. But this works for rational expressions, irrational equations. And then check it in the original equation. So let's look at example 3. We want to solve. So we have x plus 1 under 5 minus 7 over 2 equals 5x plus 9 over 2x plus 2. Okay. So I'll give you half a second to see if you can figure out what the LCD is, or just pause it. But the LCD in this case is going to be 2 times x plus 1. I just factored this. I needed the 2 and the x plus 1, so this is my LCD. So I'm going to multiply this times 2 times x plus 1. Going to multiply this times 2 times x plus 1. Going to multiply this times 2 times x plus 1. Okay. So in this first one, the x plus 1's cancel. The second one, the 2's cancel. And this cancels this. Okay, so let's see those. So then that leaves us with 10 minus 7x minus 7. So I did a couple of steps there. Equals 5x plus 9. Okay. I'm going to add the 7 and subtract the 9. So then I'm going to have 10 minus 7 minus 9 equals 5x plus 7x. So then I get 12x equals a negative 6. I'll continue over here. So then x equals a negative 1/2.